And welcome everybody to the Daily Space Weather. We'll break down what's going on with the sun and plenty more. A little bit of an SDO eclipse going on there. We'll talk about it here at the Smash News Network, the Spusted Name of News. And thanks for tuning in, by the way, all of our stargazers. That's the past 24 hours in SDO, 171 angstroms. The moon there, sweeping across the imagery. And here is an equatorial zoom. We do have some other CMEs, coronal mass ejections, to cover. We have some more active regions rising in the eastern limb. Also some growth of sunspots in the northwest. So we've got a solar flare watch emerging in the northwestern limb as well. Likelihood of large flares now going up. Here's what's going on in the northeast. Fantastic views there of filaments, active regions, some coronal holes there also visible in the 171 angstroms Solar Dynamics Observatory AIA instrument wavelength. Here's a new active region, likely a sunspot rising in the southeast. And we have a decreasing likelihood of large solar flares in the southwest. Largest flare of the past 24 was indeed in the southwest, which is, I believe, right where we forecasted it yesterday. Next, we'll take a look at sunspots here from SDO Continuum. That is December 12th and December 13th to date. Again, growth in sunspots in the northwest. A little bit of growth in sunspots in the southeast as well. Also, another couple of active regions rising. Over the eastern limb, here is the SDO colorized magnetogram for the same period of time. December 12th and December 13th to date. Now we're going to take a brief look at volcanoes and earthquakes and so on. First, take a moment to press the like button and visit the links below the video. Yeah, visit the links below the video in the description. We painstakingly put the links there and created a massive web ring to benefit people like you. To help propagate these things known as facts on the internet, smashomash.com is the homepage. And welcome to the Neo-Renaissance. It's an exciting time to be involved in things like astronomy, astrophysics, cosmology, etc. So visit our links and help us out. That'll help us to continue making these videos publicly visible, free for all to view, and keep the videos existent. You want to become a member of the Smash Team? Smashomash.com/Smash Team, kind of like Patreon, just way better. It's our own subscription services site. It has vastly superior capabilities to Patreon. Smashomash.com/Smash Team, and thanks to our gold and silver Smash Team members especially, there's also a bronze level, which will cost you $0 per month. Just log in and click posts to see the posts for your level. Smashomash.com/Smash Team. Also, don't forget to participate in our Ask a Particle Physicist segment. The deadline is tomorrow morning, so when I get up tomorrow morning, I'll be submitting some kind of a question to our particle physicist here, Mr. Bagashov. You can submit questions if you like at smashomash.com/forum. There is a general science forum there where you can ask a question to a particle physicist. It's free, by the way, at the forum, smashomash.com/forum. You want to ask a particle physicist a question? We want to get it answered for you. The following are paid endorsements. Finish Line Dry Lubricant. If you need lubricant on your chain, perhaps try the Finish Line ceramic Teflon product. It is the slipperiest lube that I think I've ever used in a long, long time. Make sure you apply it to a dry chain, by the way, a dry, clean chain. If you need a chain cleaner, check out the Park Tool Chain Scrubber and some degreaser. But that Finish Line Dry Lubricant, that is my endorsement for dry lube. Just fantastic chain lube there. It'll increase the life of your chain quite a bit, and perhaps even your bike overall. Another paid endorsement is our Hemp Lucid link. You can find it linked below the video. as we go out of our way to increase the probability that this channel will become a sustainable operation as opposed to having an operating loss of $70,000 per year. Hemplucid.com. Enter the promo code SMASHOMASH10 to save 10% on checkout, whether it's on pet CBDs, THC-free products, body balms, stacks like Stress, Immune, and Focus Stacks, Focus Mushroom Gummies. Lots of products available there at hemplucid.com. Hemplucid.com. Enter the promo code SMASHOMASH10 to save 10% on checkout. Thanks to everybody who has helped the channel out. Today's featured product is from our merch shop. And by the way, act now to save big time, up to 40% savings site-wide at Redbubble. Today's featured product is do not pole vault the Caldera, because if you're going through hell, keep going. Don't worry, folks. Interest rates are going to come down soon. So things are going to improve. The stock market is going to continue to skyrocket. And, space weather ain't going nowhere, folks. So if you're going on a volcanic vacation, leave that vault pole at home. Don't pole vault the Caldera. It could be unhealthful. Again, save up to 40% site-wide. Links below the video to the Redbubble shop, Hemp Lucid, Amazon, Smash Team, and more. Most of all, press the like button. If you're new to the channel, press subscribe. Do yourself a favor and get the world's most comprehensive daily space weather content delivered directly into your YouTube subscription feed. Also, the most detailed imagery of the sun you'll find anywhere. Check out our shorts if you don't believe me. Don't worry, folks. I've only gotten in trouble for telling the truth. Yeah, I've only been in trouble for telling the truth. So apparently, that remains controversial in the year 2023, and let's get into volcanoes. So first of all, Krakatoa is continuing to erupt. There's a great image of Krakatoa. Dag, the daughter of Krakatoa there, sending some volcanic ash into the atmosphere. Krakatoa continues to erupt. Great name for a volcano, by the way. Krakatoa! It sounds like a volcano. And there's a location of it, conveniently displayed on a map. It's producing a 4,000-foot ash plume. Merapi is producing about a 8,000-foot ash plume. Semeru producing a 14,000-foot ash plume. Merapi a 12,000-foot ash plume as it explodes. Flight level 120 over Merapi. Dakono, 8,000-foot ash plume. Aoba, no reported activity during the last 12 hours, but an eruption did occur yesterday. Santiaguito exploding, flight level 150. Fuego exploding, flight level 150. Nevado del Ruiz exploding, flight level 210. Sangay exploding, flight level 200. Revenador exploding, flight level 145. Sabancaya, the world's largest volcano right now as far as eruption goes, exploding. 24,000-foot ash plume over Peru from Sabancaya, and possible volcanic ash emissions from Ubinas as well. Next, we'll go to seismic activity. There are the past 90 days of seismic activity. Here are the past 24 hours. We'll cite quakes of a 5 or greater magnitude, starting out with this one at Vanuatu. That 5.1 was at 3:04 Universal Time this morning on December 13th. There was also a 5.4 less than an hour later in the southeastern Pacific. And then a lull in 5 and greater magnitude quakes until a 5.3 occurs very far north there in the Norwegian Sea in the Arctic Circle there. A 5.3 at a very far northerly location. And then a 5.5, so a little foreshock there. A great example of a foreshock. 50 minutes between the 5.3 and the 5.5. Last but not least, at American Samoa, a 5.0 came through at 2022 Universal Time. And let's get back to space. Space, a frontier. These are the voyages of the SDO. So there's the fantastic 304 angstroms wavelength depicting ionized helium. And again, the most active region, the T-mass, the most active sunspot, was actually down there. So there was an nearly M-class flare. It was like a C 9.4 or something like that. So that was the only spot where we saw a significant intensification of the X-ray output. And let's get to some more space weather facts. So the 10.7 centimeter radial flux is now down to 135. It's up a little bit from yesterday. So the radial flux now up to 135. It comes from the upper chromosphere and lower corona, if you're wondering where it emanates from. The 10.7 centimeter radial flux, there it is in the 1-year display from solon.info. 135 is the current radial flux number. So that's the 1-year graph. The black line there represents the radial flux. And NOAA's not forecasting any geomagnetic storm conditions. So continuing on here are the past 4 hours of Earth's magnetic moment from space. Let's bring that back and play it all the way through. So we did see some brief periods of geomagnetic unrest. We are seeing some sporadic minor coronal mass ejection impact activity. It's not enough to produce geomagnetic storm conditions, but some minor perturbations in the solar wind. Again, that's the past 4 hours of Earth's magnetic moment from space. Here are the last 4 hours of Earth's magnetic moment from the ground. This depicts magnetic flux density in nanotesla. And if you want to read about the space weather modeling framework and how it creates the model, just click on the Details tab on the Geospace Magnetosphere Movies page. It'll give you a link to the space weather modeling framework. Next, the KP index currently at 2.33, geomagnetically calm conditions. KP 2.33 is the current situation at the space weather station. Next, solar wind here, quite slow and quite diffuse as measured by the ACE, as measured by the Discover. A little bit more interesting here. We are seeing a little uptick here in the solar wind density, also an increase in the magnetic field strength, and a strong negative BZ. So it looks like another event here coming in just in the past few hours. Right in there. Looks like a minor CME impact. Another coronal mass ejection showing up there, marked by an increase in the magnetic field strength, a change in the magnetic field vertical component, changes to an increase, by the way, in the solar wind density, and a decrease in the solar wind velocity. So sometimes CMEs come in at a slower speed. And we also are seeing some variations here in the solar wind speed. So those are two separate regimes, a slower and a faster moving series of plasma. That is the solar wind for the past 24. GOES magnetometers are next, and no major changes in the GOES magnetometers. Fairly smooth readings for the past 3 days. Again, only minor perturbations there in the solar wind parameters. And next, our top view ecliptic plane field plot. And we have a South Pole current sheet imminent. So at any moment, Earth could snap into a South Pole sector of the heliosphere. There's the latest image. And it's quite turbulent over there, actually. So it looks like a North Pole current sheet is still sort of in effect. Anyway, there's the last image. Again, we could see Earth snap into a South Pole sector at any moment. There is magnetic indecision east of center longitudes on the closest star. Here's our line of sight ecliptic plane field plot. And you'll see a bunch of movement happening there over on the left side of the solar disk. Again, magnetic indecision. Keep in mind the magnetic environment can change with basically zero warning. And here's our line of sight field plot. You'll see that moving around quite a bit as well. As we see a little uptick in sunspots, which you can expect to continue for the next nearly 1 year. Last but not least, our line of sight coronal hole plot. And we've got some South Pole-oriented coronal holes here rotating into view. Let's bring up the last image, and then we'll switch to SDO. So actually, at the moment, what we've got is these are south, And all of the rest of these are North Pole coronal holes. So that's the polarity of the Earth-facing coronal disk. And you may see a CME happening in this area. That could be including earthly directed components. We'll get to it. What's that? You want a closer view? I think we can accommodate that. There's the equatorial zoom. Great view of active regions, coronal holes, the extended corona, also filaments. And of course, the moon, making a little appearance there, obscuring large portions of the solar disk for a couple of hours. It's eclipse season for the SDO. Moving right along to sunspots, which are next. There you go. There are sunspots from ROB, the Royal Observatory of Belgium. And we're right at the average right now, which is, let's see, 110, 120. About 122 is the current smoothed average for sunspot number. Here's our flare probability monitor and scoreboard. And we've got, again, an increasing likelihood of large flares in the west. So mainly in the northwest. The likelihood of large flares in the southwest is dropping. The likelihood of large flares in the northwest is rising. Here come sunspots from SDO continuum. Again, you'll see some sunspot growth in the upper right. Also some sunspot growth in the lower left. Those are the northwest and southeast limbs respectively. So as these groups get closer and closer to the limb, the likelihood of a large flare from those groups rises as well. Next, energetic particles. We ain't got none. The GOES proton flux. Still no spikes here. A surprisingly long time with no spikes in the proton flux. No solar energetic particle events to report on for weeks on end. And next, the X-ray flux. The largest flare was about a C9.4. Peak flux was around 1510 universal time this afternoon on December 13th. And here come some more images of the closest star. And indeed, there is that nearly M-class flare in 94 angstroms. There's a great view of that. The T-mass, the most active sunspot. We got it in 131 angstroms as well at the same zoom. So there you have it. There's your extreme close-up of the most active portion of the closest star. And we'll zoom out to show the equatorial view as well in that same wavelength, the SDO AIA 131 angstroms wavelength. It's good times, good times. And next, let's take a look at a star chart. This is what's going on overhead. That is from skyandtelescope.org, skyandtelescope.org. Put in your location, click now, and you'll get your own star chart. That's what's going on over our head. Saturn making its way to the west. Next, your solar system forecast. We'll show you where things are today, which is right there, as well as where things will be in 1 week. So let's advance this as Earth moves around to the lonely side of the solar system, the side with no gas giants. That's where things will be in a week. Mercury speeding past here. So that's the current situation. That's the next 7 days of solar system. And next, our astronomy photo of the day, apod.nasa.gov, apod.nasa.gov. This is an awesome nebula. The red portion is hydrogen, and there is a lot of dust. The blue is probably oxygen, I would suspect. That is known as the Heart Nebula. Yeah, the Heart Nebula, also known as IC 1805. Splentacular imagery there from theastroenthusiast.com and William Osling. Shout out to William Osling. Fantastic imagery there. That's located about 7,500 light years distance. And it's quite a complex nebula. The portion that we're showing here is illuminated by some young, hot blue stars, I suspect. Once again, it's known as the Heart Nebula. apod.nasa.gov is the location. Next, doing some CMEs. What do we got? I want to know. What about you? So here's the scenario. These are CMEs from yesterday. And see yesterday's video to see if that is earthly directed. We don't call the daily space weather video for nothing. Here are today's CMEs. An additional 62 frames. There may be one containing earthly directed components. I suspect there actually is. Let's take a look at C3 as well. So here's C3 and C2. Right toward the end of the video, there looks like there might be an earthly directed CME, another coronal mass ejection, headed our way. Fingers crossed for that. And if you are spooked of CMEs, I just feel sorry for you. So there's one out of the west. That does not look earthly directed. And right at the end, the final few frames here, you can see some activity there. Looks like it could be an earthly directed CME. Let's take a look at stereo A as well to help verify that. It looked like it was mostly off to the east. Stereo A is located right here where that red circle is located. And here is the raw coronagraph on the left, difference imagery on the right. So there's a CME off to the east and southeast. And then another event out of the west. That was quite early this morning. And then right toward the end. Oh, that looks like it's out of the west. All right. Interesting. Interesting indeed. Let's take a look at our custom coronagraphs next. That is a 24-hour video for you. All right, maybe it's not earthly directed. Let's zoom in a little closer. Okay, so I do suspect there is an earthly directed CME in there. It came from this area right up here. So that one likely has an earthly directed component. Once again, we can expect that to arrive sometime after midday on December 16th. So yet another minor CME impact on the way, folks. Here's a little closer view of that. We've dropped the LASCO C3 and included the SDO 304 angstroms wavelength. That CME originated from right up here, and it was from somewhat around midday today. So that's my story, and I'm sticking to it. Here is just the SDO 193 plus 304 angstroms wavelengths. And let's move on to filaments. Filaments are next, and this is what they look like at the moment. There's the Earth-facing portion of the solar disk. The Putin and Lukashenko filaments are setting in the southwest. We've got quite a few in the east, mostly all east of center longitude at the moment. That's Cerro Tololo, Chile's ground-based hydrogen alpha imagery. We'll also show the grayscale so that it shows prominences. Again, we've got a new active region or two about to rise over the eastern limb, so we'll be monitoring that. The eastern limb there, featuring some new sunspots likely to rise soon. Before we get to bonus features, we'll also cover the last about 3 hours from the GOES 18 SUVI. There you have it. Massive filament hanging out down there in the southeast. Anyway, here come bonus features. First, satellite charging hazards. At the moment, just minor surface charging there over the Middle East. Surface charging is caused when low-energy electrons build up on the outsides of spacecraft. That's not likely to damage a spacecraft, but it could cause some minor communications glitches, not likely to cause any major communications failures. Electron flux here, quite a bit lower than it was. That is the past 3 days as measured using radiography by the GOES 16 and GOES 18. There is the 1-year graph to contextualize the electron flux. Solon.info is where you can find that if you like. Here we're seeing a dip in the electron flux as forecast by both NOAA and our channel. Green boxes are the forecast, yellow diamonds are the observation. We'll also show the layer where it's measured, which is the F layer, right about there. Here's 300 kilometers of altitude's vibrational frequency. It's in megahertz. We used to measure computer clock speeds with megahertz. Now, the ionosphere, as we measure computer clock speeds in gigahertz, billions of vibrations per second. Megahertz are millions of vibrations per second. And here's the anomaly gram as well. Anomaly in megahertz from the 30-day median. So quite a bit of low-frequency anomalies there showing up on the anomaly gram. We have had some space weather coming in, so it's been minor, but it's all been in the forecast. Anyway, here's the latest image, 2300 universal time for the ionogram. There's the anomaly gram, 2315 universal time. We'll also show the total electron content in the global ionosphere nowcast. But first, don't forget to follow us on Twitter. Do you follow us on Twitter yet? x.com/smashomash. You know, thanks to our 0 new followers over there, the interaction is just pathetic on all social media. It's enough to make you delete your account. Next, our global ionosphere nowcast, and that's what's going on up there. If you've unplugged from social media entirely, we don't blame you. The censorship is as pathetic as it has ever been. Between March 2020 and now, it's really not gotten any better. In fact, in many ways, it perhaps has even gotten worse. So there's our global ionosphere nowcast depicting total electron content and radio frequency, the maximum usable radio frequency. So GPS users, pay attention to the left. Radio users, pay attention to the right. We'll also show total electron content by itself, which is free electrons to about this level, the inner portion of the outer Van Allen belt. It's at about 12,500 miles of altitude, and here is the total electron content forecast. It's the free electrons from your GPS satellite down to your handset. And no, the apocalypse is not being predicted by any of this. Everything looks just fine. Just fine. If you're spooked by this, please unsubscribe from the channel right now. And if you're in a cult, please unsubscribe from the cult right now before it evaporates your bank account. Anyway, let's take a look at this. This is going to be the new most likely place to see a large sunspot. This little triangle of sunspots right up here. And this one right here is the most complex. So we've got an increasingly likely chance of seeing large flares in that northwestern limb. And let's move on to meteorology because it's about that time. It's about that time. So now we're looking at the significant wave height and surface winds. The world's largest waves are about 40 footers here, south of Greenland and Iceland. So those are the world's largest waves by quite a bit. Again, that depicts surface winds with the animation and significant wave height with the color gradation. So yeah, those are the world's largest waves right now. And let's get to regularly scheduled meteorology. These are the surface winds of the east. These are your jet streams. Jet streams of the central world seen here. Here are your surface winds. Jet streams of the west. Surface winds of the west. And there are your jet streams. So that's what's going on. We'll also show clouds and fog. That is a shortwave radiation map, space-based system that depicts infrared radiation at 3.9 micrometers. And here's a little closer look. There's an anticyclone over the east central part of the U.S. It's an upper level anticyclone here. It's over like Indiana and Illinois, I believe. You'll see that here momentarily. That is clouds and fog, a bunch of low clouds there, south of the Great Lakes region. And here you can see a great view of that anticyclone. So you've got this huge high pressure zone right here, accompanied by a strong clockwise rotation as you get with anticyclones in the northern hemisphere. We've also got a weak low down here, but it's strong enough to be pulling a lot of air toward it because of the relative low pressure of that area. So there's your full pressure map from windy.com. Windy.com, they got a great mobile app. Check it out if you like. Here's our weather.gov map. Weather.gov. Get your local weather alerts. Some winter storm warnings there in New Mexico, Texas, and Colorado. Here come some forecasts, starting out with the GFS 72-hour jet stream forecast. So you see this pocket of cold air that's making its way across the U.S. That's cold Canadian air. And the jet stream is in charge of it. So this is largely the culprit for moving your weather patterns from west to east. The jet stream, depicted here by the 250 millibar winds. The GFS 72-hour forecast for those winds. Next, our pressure and precipitation forecast, the same model, the GFS 72-hour. And a very strong low is going to form here in the northeastern Gulf and then smash into Florida there. That's going to be a significant event there. The Florida Gulf Coast. It's going to get a little bit kaplastered in about 3 days. Lastly, the accumulated positive snow depth change forecast in inches for the same model, the GFS 72-hour. We show 72-hour models because they tend to be accurate. And if you're viewing YouTube channels that show you like 10-day long and 2-week long forecasts, you should laugh and laugh and laugh and laugh because those are extremely inaccurate. Once you get to about 4 days, the accuracy drops off of a cliff. So that's why we show 3-day forecasts. They're accurate. That's your accumulated snow depth change in inches. Next, lightning. We did have a little bit in the U.S. at the moment. Things are pretty chill. Here's our real-time lightning map, courtesy of lightningmaps.org. Lightningmaps.org. Next time you hear thunder, frighten the natives by forecasting thunder. We're going to close out this video with the latest U.S. Doppler radar. Also clouds and fog. And don't forget water vapor. Here's a recap. Doppler radar systems show vertical motion in the air column. They are ground-based systems. And they're used to show things like precipitation. Space-based systems like the NASA GOES Interactive Weather Satellite Suite, they show, in this case, infrared radiation from space, 3.9 micrometer infrared radiation, and here is 6.19 micrometer infrared radiation, which shows the dry air, the moist air, and all in between. Time to close this thing out. Thanks for tuning into the Smash News Network, least busted name of news. Congratulations on realizing the channel exists. I've been your host, Dan, a.k.a. Smash-O-Mash, signing off. And until tomorrow, may that solar wind be at your back. While I go back to the bunker again, I finally quit my cult, but they did not refund my money.